All right, first question, what are the conditions for a limit to exist? So for a limit to exist, we just need the left side of the limit to equal the right side of the limit. If I want it to be continuous, I need the left limit, so let me write this. As x approaches c from the right, that has to be equal to x approaching c left from the right. And then for continuity, this also must be equal to f at c. And then for differentiability, the derivative has to be equal on either side. The limit derivative, x approaches c from the left. Here, I want both of these to be 0, so this less than 0 means it must be decreasing. This 0 means it must be concave down. So that looks like this, and the decreasing part, so that is point T. Here, I'm going to, if you plug in, you get 0 over 0, so I'm going to factor out x plus 2, x minus 1. That's negative 3 over x minus 1. Now I'm ready to plug in again. Negative 3 over negative 3 is positive 1. Just a different pen. All right, here we're looking as x approaches infinity. Doesn't matter if it's negative infinity or positive infinity. This is Bodhi eats DC. So I'm going to do negative 1/2. Derivative, I'm going to use quotient rule, low, d high, minus high, d low. Underneath the low squared goes. X squared would be 4. F prime of x is negative 1. Minus f of x is 4. 2x would be negative 4. Over x squared would be positive 4 squared, so over 16. This is negative 4 plus 16, which is 12 over 16, which is 3/4 A. Here we're looking for the tangent line. So first let's find the y value. So secant of pi over 4 is the same as just 1 over cosine of pi over 4. Cosine of pi over 4 is, go to pi over 4, that's root 2 over 2. That's 1 over that, so that's just 2 over root 2, which is just root 2. So now we're between three of them. We need to find the slope. So y prime is secant tangent. So secant of pi over 4 times tangent of pi over 4. So tangent of pi over 4 is easy because pi over 4 is when these are both the same, so sine over cosine is just going to be 1. And then secant of pi over 4 we just found is root 2. So root 2, this one, b. Y minus root 2 equals the same slope, x minus pi over 4. Finding derivative, 2x plus, product rule here, 1y plus x dy dx minus dy dx equals 0. I'm going to move, I just need to plug in here. Okay, I'm going to move these over, so I've got 2x plus y over 1 minus x, and then now I'm plugging in these x values, 2 times 3 plus negative 1 over 1 minus 3. That gives me negative 2. This is 6 minus 1, which is 5, so negative 5/2. Concave up, so first I need to find f prime. A lot of you got tripped out by this, so I'm going to rewrite it. It's just 1/6 x cubed minus x squared. So then f prime, this one goes away. That's going to be negative 1/2 x squared minus 2x. F double prime is going to be negative x minus 2. Make this 0. That gives me x is negative 2. Yeah. So then make your number line, negative 2. If I plug in 0, this is negative. 0 is over here. This is positive. So it's concave upwards from negative infinity to negative 2. A. Which of the following is not true from this f prime graph? F is increasing from 2 to 4. This is positive, so that is true. Local minimum, x equals 1. That is not true. That is a point of inflection. The minimum is where it goes from negative to positive, so that'd be at x equals 3. Maximum at 0 goes from positive to negative, so that's good. And inflection point at 1 because it changes from decreasing to increasing. That is true. Here you are going to get 0 over 0. I'm not going to check it, but you do. So then we'll take the derivative. That's e to the x plus sine x minus 2 over 2x minus 2. E to the 0 is 1, sine of 0 is 0 minus 2, over 0 minus 2 is negative 2. That gives me negative 1 over negative 2, which is then positive 1/2. We are going to use the tangent line to approximate. So tangent line would be y minus 2 equals 5x minus 3. We're going to plug in 3.5. Minus 3. This is 5 times 0.5 plus 2. This is 4.5 then. 2.5 plus 2. Right, we're looking at the behavior at x equals 3. So to check the limit, we need to check on either side, left and right. So we're going to plug in 3 squared minus 5 times 3 plus 8. That's negative 15. 9 minus 15 is negative 6 plus 8, which is 2. Hopefully I did that right. Yeah. And then if we plug in here, I get what I feel like I should be getting. 9 minus 15 plus 8. That gives me 17. This is 2. Oh yeah, 3 minus 1 is definitely 2. Alright, so the limit exists. It's or equal to here, so it is continuous. Differentiable, you have to take the derivative, 2x minus 5, and this one would just be 1. If I plugged in x equals 3, that is 6 minus 5, which is 1, so the derivatives are also equal, so all three are true. Here, derivative of natural log is 1 over, leave the inside the same, then multiply by derivative of the inside, which is 1 plus e to the x. Then of 0, that would be 1 plus 1 over 4 plus 1, so 2 over 5. Here, we're going to work our way outside in, so f prime of g of root x times g prime of root x times, now I'm not in the inside yet because I have root x right here. Derivative of root x, x is 1, that's x to the 1/2, so derivative would be 1/2 x to the negative 1/2, so that's 1 over 2 root x. And then now I'm ready to plug in my x value. So this is f prime g of root 4 is just 2, so g of 2 is 1, and f prime of 1 is 4, times g prime of 2. G prime of 2 is 1, times 1 over 2, root x is 2, so that's 4 times 1 times 1/4, so that gives me positive 1. Here we're going to use this, so y minus, so first let's find f of g of 3. G of 3 is 4, so f of 4 is 4. So y minus 4 equals, now I need to take derivatives, so that would be f prime g of x times g prime of x. G prime of 4, we're doing 3. G prime of 3 is 2. And we already found that g of 3 is 4, so we need f prime of 4, which is 2. So this is 4, so 4x minus 3. So this is the tangent line at 3, and now we just plug in 3.1. So this just is 4 times 0.1, which is 0.4. Add the 4 over is 4.4. Here, I'm going to rewrite this as sine of 5x all cubed. Now when you take derivative, that's 3 sine of 5x squared. Multiply by derivative of the inside now, which is cosine of 5x. One more inside times 5, so this is 15 sine squared of 5x times cosine of 5x. The next one is the limit as x approaches 8 of some h going to, or oh my gosh, h approaching 0. I see over h, I see a function as x plus h. So this is keywords or key things here is h approaching 0 and over h and x plus h. This is just the limit definition of a derivative. So what this means is derivative of tangent, and derivative of tangent is just secant squared x. So this is my answer. I'm not looking for it at a value, right? I just want the derivative of tangent x. Here we got to use product rule, so 1y plus x dy dx equals 1 cosine y plus x negative sine y dy dx. Oh my god, I made this nasty. E to the xy, now I need to use product rule, 1y plus x dy dx. Oh dear. Let's get all of the dy's over. So I've got x plus x sine y minus x e to the xy with their dy dx's. And then on this side, right, I move these two terms over. I still have cosine y and y e to the x. Cosine y plus y e to the xy. And then I subtract this y over. So then to get dy dx, it's just going to be that over this one. Let me double check, that's the same. Oh yeah. I have different signs. Are all my signs different though? You guys probably think I'm crazy. Okay. Hopefully I didn't mess up a sign there. If you can, first person to tell me gets a donut point. Alright, here we have f double prime. We want to know where inflection points are. That is going to be 0, negative 1, and 2. This one has a power of 2, so actually it's not changing signs over. It would only change signs over here. So at negative 1 and 0 only. Here, natural log of 1 is 0. This is going to be 1 minus 1, so you get 0 over 0. So I'm going to take product rule, 1/2 x to negative 1/2 natural log of x plus root x 1 over x over 2x. This is just going to be 1/2. Well, no, this goes away because it's a natural log. This is just 1 over 2. So 1 over 2b. These are both positives. That means E increasing and concave up. So A is the only one that is concave up right here. And it's increasing. So A. Which of the following statements is true? We're looking at f prime. So decreasing from negative 1 to negative 1. Nope. F prime is negative for decreasing. That means it's concave down. Yeah. F is increasing from 1 to 2. From 1 to 2. Nope, it's actually a negative. F is not differentiable at negative 1 here. So here, this right here and right here is not differentiable, but that's f prime, which means that f prime is not differentiable. If I have a derivative at those points, which is what f prime is, then it was differentiable. It's increasing from negative 2 to 0. This was positive, so yes, it was increasing. And if it was not a minimum, it was a maximum here, from positive to negative. All right, quotient low, d high, minus high, d low, underneath the low squared goes. So I'm going to write off f of 6, f prime of 6, g of 6, and g prime of 6 off to the side. So 1, 2, 3, 4, 5, 6. So this is g of 6 is 2, f of 6 is 4, g prime is just the slope, which is negative 2, and here this slope is negative 1/2. So now g is 2, f prime is negative 1/2, minus f, which is 4, g prime, which is negative 2, over g squared, so over 4. This is negative 1 plus 6, this is positive 5/4. We want to know where it's decreasing, so first find f prime, that's 2x e to the x plus x squared e to the x. Take the x e to the x out, and that's 2 plus x. So then x is negative 2 and 0 for this guy. So 0, negative 2 and 0. Let's plug in positive 1, that would be positive. If I plug in negative 1, this is positive, that's negative, so that would be negative. So it's decreasing between negative 2 and 0, which is B. For relative minimum, if f prime exists, then we know that f prime is 0. Does it have to exist? No. It could be undefined. It could look something like this. So no, could be undefined, right? Not necessary for f prime to exist. And if f double prime does exist, what do we know about f double prime? Well, this would be concave up, so f double prime would be positive. This is f prime. We're going to be looking at 2.